Back to my channel, The Machine Brain. So far we have discussed the process of data preprocessing in data mining and structure of data preprocessing and the steps involved in data preprocessing and data cleaning. Today we'll discuss data integration, okay, and also data reduction. And then next video we'll discuss data transformations and concept hierarchy generation and data discretizations. Okay, today we'll discuss data integration and data reduction. First, here in data integration, the multiple heterogeneous source of data are combined into single data sets, right? Here multiple heterogeneous sources means whether it will be numeric data sets or alphabet data set, or it will be electric data sets. It contains mobile phones, telephones, the electric data sets, and related to another data sets, for example cities, countries. These are all heterogeneous source, okay, heterogeneous source of data are combined into single data sets. These single data sets contains both all numeric and electric and city data sets is combined into single data sets. Okay, this involves in data integration, it involves two steps. One is tight coupling and loose coupling. In tight coupling, data is combined together into physical location. Okay, we already discussed in data preprocessing also. Okay, here data is combined together into physical location. A is one data set and B is one data set. These data sets are combined into physical location. We'll create one separate location for C, and these combined data will be stored into these physical data sets. And the main drawback is that here we cannot access these A and B data sets is contained in a C. We cannot access. Okay, it is difficult to access. Whereas in loose coupling, we will create interface. Here we will create interface for these A and B data sets. We will create interface for this A and B data sets, and data is combined through interface and also accessed through interface. Okay, these data will be combined through interface. Okay, we will create interface for this, and these combined data, and data is combined through interface. Data is combined through interface, and we can access if you want any data related to A and B, data sets related to A and B, we can access through this interface. Okay, data remains actual database only. Yeah, data remains actual database only. Okay, and that's all about data integration. Next we will discuss data reduction. In data reduction means it will reduces the data, the volume of the data will be reduced to make analysis easier. Okay, so that if the data will be reduces, there will be more performance, right, than compared to poor performance. It can be done by lossy and lossless also is there. Yeah, lossy means the data will be lost for somewhat, lost, and lossless means data will be not be lost, and data will be not be lost, and we can do analyze easier. Okay, so let us discuss the methods of data reduction. Okay, here there are four types of data reduction methods: dimensionally reduction, data cube aggregation, attribute subset reduction, and numerosity reduction. Okay, we'll discuss these methods first. Dimensionally reductions. Here dimensionally reductions reduces the number of input variables in the data sets. Okay, we'll reduce inputs are there. these inputs will be reduces, which is not highly relevant for pre-processing, and irrelevant input values are to be reduced, so that the more performance will be there for data pre-processing. Okay, because large input variables have poor performance already. From these large input variables have low performance, so that will reduce the number of input variables. Okay, next, data cube aggregations. A data cube aggregations means this data is combined to construct a data cube. Okay, a data will be combined and will construct a data cube for these data sets. Okay, so that noisy data are removed, and redundancy will be removed by removing duplicate values in data cube, so that redundancy will be increased. Okay, we are already seen in data warehousing, data will be converted into data cube format. Okay, this is data cube. In data warehousing, it is a multi-dimensional, so we all converted into a cube format. Attributes also will be there. Next, attribute subset selections. Here, attribute subset selection, highly relevant attributes should be used. We will ignore all other attributes which is not a need for data pre-processing. Okay, we will use only highly relevant attributes only we will use in attribute subset selections, so that by removing these irrelevant attributes, the data will be reduced, so that the data pre-processing has more performance. The next, numerosity reduction. Here, in numerosity reduction, we'll store only a sample of data instead of entire data. Okay, instead of entire data, we'll store only sample of data or model of data, so that for reference purpose it is very easy. For example, consider a class contains 60 of records, right? A class contains 60 of records. We will store only 6 to 7 records only for future reference, so that here numerosity reduction also, it will store only sample of data instead of using this entire data. Okay, that's all about numerosity reduction, attribute subsets, and dimensional reduction, data cube aggregations, and data reduction, and methods of data integration. From next video we will discuss data transformations and data discretization, concept hierarchy generation. Okay, thank you.